Today, we are the Team Iceland. In this video, we are going to discuss about the basic knowledge of the system, theories involved in the system, the different computations, designs, troubleshooting, and maintenance. This ice plant can freeze water to ice. It operates as single vapor compression cycle. It can be useful in different large-scale production. Comparing it to conventional refrigeration that we can find in our home, it is much faster. Principle of this mini ice plant. The liquid refrigerant absorbs heat from the secondary refrigerant, which is circulated around the refrigerated space in the evaporator. The secondary refrigerant absorbs heat directly from the refrigerated space and transfers this heat to the primary refrigerant, which circulates in the evaporator coil. The primary refrigerant absorbs heat in the form of sensible heat and latent heat, and undergoes change in phase. The low temperature and low pressure vapor refrigerant so obtained is sent to the hermetically sealed reciprocating compressors, where it is compressed to the high temperature and high pressure vapor refrigerant. The high temperature and high pressure vapor refrigerant from the compressor is passed to the cross-flow evaporated condenser, where it loses its latent heat of the condensation to the cooling medium to undergo change in phase and gets condensed to high pressure liquid refrigerant. The high pressure liquid refrigerant from the condenser is throttled in low pressure liquid refrigerant by the expansion valve without change in phase. It is then filtered to remove any impurities that it have been acquired in the system and finally sent again to the evaporator. Of the components. Now the cooling capacity required is determined. Selection of appropriate components can be done. The selection starts with the compressor, since it will determine the cooling capacity of the system. The condenser, expansion device, and evaporator will then be selected based on the compressor activity. The compressor was selected based on its cooling capacity, since it is known that the cooling required based on assumed value was 0.41279 kilowatts. Selecting a compressor with a higher cooling capacity is appropriate to compensate for losses due to insulation and etc. 1/2 horsepower compressor. Cooling capacity of compressor at negative 15 degrees Celsius is equal to 740 watts. Actual cooling at top is equal to cooling capacity of compressor minus heat loss. Actual cooling is equal to 740 watts minus 189.9 watts is equals to 550.1 watts. Time of cooling is equals to heat loss of brine over actual cooling is equal to 1491 kilojoule over 0.5501 watts is equal to 2710 seconds, and it is equal to
the selection of the condenser. Computing for the capacity of the condenser can now be done since the size of the compressor is already determined.
So this is the formula. And now the capacity of the condenser is equal to 0.935 kilowatts.
Head loss of evaporator. The effect of pressure evaporator.
Sige, ito.
Decrease the suction. The effect of pressure drop in the evaporator decreases the suction pressure, thus reducing the refrigerating effect. So it's quite significant in figure to reduce the losses to a minimum. The evaporator dimensions as follows.
Capillary tube sizing. A capillary tube is fixed restriction type device. It is a long and narrow tube connecting the condenser directly to the evaporator. A number of combinations of length and bore are possible to obtain the desired flow and pressure drop. In this computation, the bore is specified so that the length will be determined.
And then the parts that need to replace is the lid of the freezing tank. You need to seal this using an epoxy. And then next is the leak in the condenser. Because there
Different components of an ice. First, the compressor. Second, condenser. Then, the cooling tower. Low pressure gauge. Capillary tube. Filter dryer. Diameter. Voltmeter. And the evaporator.
The cooling tower. It helps the condenser to reject heat. The different functions. First, the condenser. It is used to compress the vapor refrigerant from the evaporator and to raise its pressure so that the corresponding saturation is higher than that of the cooling medium. Second, the condenser. It is an important device used in the high pressure side of a refrigeration system. Its function is to remove heat of a hot vapor refrigerant discharged from the compressor.
Dryer. The function of filter dryer is to remove any physical material from compressors to enter and remove any moisture present within an air conditioning system. And the capillary tube. The capillary tube is used as an expansion device used in small capacity hermetic sealed refrigeration units such as domestic refrigeration, water cooler from air conditioner, and freezers. And the evaporator. The evaporator is an important device used in the low pressure side of the refrigeration system. The liquid refrigerant from the expansion valve enters into the evaporator.
maintenance. Always drain the condenser, the water in the condenser. Use a pump to drain the water. Then drain the water of the freezing tank. Please clean the workplace.
Keep it dry and mop the floor.